All right, so the next one is Machine Learning 101 here. This one here I thought was a lot of fun because you do actual computer vision. And what we're going to do here, this is I just wanted in another tab. Let me do that. This one is taking this. This is a famous data set used by many people to train machine learning algorithms called Fashion MNIST. I guess it's the National Institute of Standards is involved. And the point is they have a bunch of pictures of clothing items that they got somewhere, as you can see. And they're nice 28 by 28 grayscale images, and they're sorted into 10 classes like coat, shirt, and bag. So we want to teach your machine learning model to tell a coat from a shoe and so on. So here's the classes: t-shirt, pullover, dress, coat, shirt, bag, and so on. So each image is a 28 by 28 pixel thing. So that's 784 values, and they go from 0 to 255 because it's grayscale. So all it is the color from black to white. So we need a more complex neural network. We're going to have to feed in all 784 pixels and then have some layers of intermediate neurons and then have some outputs. So what we're going to have is 28 by 28 pixels of input. We're going to have a hidden layer of 128 neurons, and the output is going to have 10 neurons sorting into those 10 categories. So the input is broken up into all those pixels. The pixels are processed by hidden neurons, and then the outputs come out as a probability that it's a coat, a sneaker, or a bag, or all the other options for 10 options. So, as usual, the great thing about this is it doesn't take very much code. Again, about 10 lines of code to do this. So I'll make a new notebook. And put in that code. All right, so again, we import TensorFlow. We have training images here. Here's where you define the model. Input is 28 by 28. The hidden layer is 128 neurons, and the output layer is 10 neurons. And the training images come with a label. This is called supervised learning, where you give it some examples and you tell it what the right answer is for those examples. So it came in as images and labels. And now it can train using those labels. So now what it did here was it trains it and then it evaluates it. There's training images and test images. So what happened here is the training images and test images both came from the data. And the number of them isn't set by some kind of automatic process. I think what people usually do is set aside 20% of the input data to serve as test data. So you train it on 80% of the data, and then you test it on the remaining 20%. But we didn't specify that here. The library made some decision about how much data to put in training and test sets. Anyway, this is a much more complex task. And so here it goes. It's downloading the data. It's unzipping the data. And now it's going to run 5 training epochs. And as you can see, each one of these takes a few seconds. So it's not taking too long to do this, but longer than the previous one, where we just had some dots on a curve, like a sine curve. But see, it's like 10 seconds or something per round, and we're only doing 5 rounds of training. And you see the accuracy is going up. It's using an accuracy measure instead of a loss measure, so going up is good. Accuracy of 1 would be perfect. And here is the result. I think this is the accuracy. Let me check my instructions. All right, the two accuracies. The first one is the accuracy of the model applied to the training set. The next one is the test set. So when I did it before, here I get, oh, here they are. Okay, that's what I wondered what this was. Those are the parameters, I think, which we don't care about. So it's 89 and 87, and this time I got 89 and 87. So it's 89% correct on the training set and 87% correct on the test set. So that's pretty good. And now you can view the results. Now here, you could delete the code and replace it by this, and it will remember, or you can just add another block of code, which I didn't know how to do when I did this before. I think, what does this do? Nope, it doesn't do it. Maybe I've already forgotten how to add another block of code. plus code. There we are. There, okay, I can do it here. All right. So I run, all this is going to do is show us the results. So what this is, here are various test images. Here's the label of what it should be. And here's the output of the model from 0 through 9. So this one is supposed to be a 9, and its probability of being a 0, 1, 2, 3 was all small. And you see it had a 93% chance of being a 9. So this one is correctly labeled. Here's one that's supposed to be a 2, and it's got a 99 there. These two are supposed to be 1s, and they're correctly detected. This one that's a 6, still got it right, but you see it had a chance of getting it wrong. And if you look through here, you'll find one that it got wrong. This one looks like a pretty good candidate. This one's a 7, but it's 0, 1, 2, 3, 4, 5, 6, 7. It looks like it had trouble telling a 5 from a 7, and so on. So this way you can spot ones that failed. And now we can print out some of those images. So let's see. I think I'll settle for that 7. And this is what will show the images. So you can see what it, I'll just replace this block, or let me add another block. Doesn't matter which way you do it, really. All right. So there's one it was able to match, and here's one where it failed. And the point is there are two shoe-like options. I think one is called a sandal, and the other is called an ankle boot or something. And this one here, a sandal or a sneaker. The problem with this one, it could be a sneaker with stripes on it, or it could be a sandal with straps. And it's really hard to say which it is, and therefore the model gets confused. So it's, in that respect, it's acting just like a human. And so you can train it with more training to see if it gets better. And then you can run one here, learning with errors. All right, there's just a couple flags to find there. It looks like just one flag here. So you run model summary, and you'll find out how many parameters you've been using. So I thought that's a lot of fun, where you actually see it learning to recognize visual images.